Good morning, my YouTube viewers. It's Crystal here. I want to make another code review for you. In this code review, we're going to be talking about sklearn's semi-supervised label spreading. So in a previous video, we talked about label propagation. So in this video, we're going to talk about label spreading. And label spreading is very similar to label propagation, but it just uses the algorithm differently, but it's a similar algorithm to label propagation. And this is for semi-supervised learning. Semi-supervised learning is when you have some labeled data but some unlabeled data, and then you attempt to label the unlabeled data. So what we did was we created this program using Google Colab, which is a free online Jupyter notebook. And Google Colab is really good, except for the fact that it doesn't have an undo function. So you have to be very careful not to delete or overwrite your data, because if you do, there's a possibility you won't get it back. You could go into the save history here and try to retrieve the code in the save history. So now that we've covered Google Colab, then what we will do is we will talk about the code that you need for label spreading. So the first thing we do after we have created the program is we are going to import our libraries. So we're going to import NumPy, which carries out numeric computations and creates NumPy arrays. We're going to import Pandas, which creates data frames and series and does data processing. We're going to import matplotlib.pyplot, which visualizes the data points by plotting the data points onto a graph. We're going to import sklearn, which is a higher level graphics library written on the back of matplotlib. We're going to import warnings because I didn't want to see the warnings on this program, so I stifled the warnings. So after we have imported our libraries, what we're going to do is we're going to read our data in. And so we used a Sonar data set to do that. And then so we read it in with the Sonar data set, and it has 208 rows by 61 columns. And then so what I decided to do was I decided to make a heat map, and I think that the visualization of the data points is really nice. But this is your heat map, and this is what the heat map looks like. And so what I wanted to do was I wanted to reduce the number of columns. So core equals data dot core brackets f comma ax equals plt subplots big size equals 12,9, and then go sns.heatmap brackets core comma vmax equals .8 comma square equals true. And then so we've got our heat map. And that's the beautiful thing about these data science projects, is you can visualize your data and see what the data looks like in memory. So after we created our heat map, we want to see what core looks like, and core just tells you the how each row correlates with another row. And now what we want to do is we want to remove those columns that have a higher correlation, because they're just redundant and they just introduce noise into the system. So I think we were able to get rid of 3 columns. 3 columns had a high correlation, so we reduced it by 3. And now what we want to do is we want to shuffle the data set. So df equals data.sample, brackets, frac equals 1, that's 100%, comma, random state equals 42, df copy underscore copy equals df copy, brackets, y orig equals df underscore copy, class, and then df. So you can see it again, and it's been shuffled. So now what we're going to do is y orig value counts. You have 111 zeros and 97 ones, and you don't have any null values. So now what we're going to do is we're going to do a scatter plot to see how we're going to do a scatter plot to see how a 2D representation of where the examples fit into memory. So these are your scatter plots, and you can see that you've got a few outliers as well. And it only uses the first 2 columns of the data set, and it uses y orig, which is, again, these graphical representations are really good. And now we're going to do a 3D representation of where the scatter plot fits into memories, and you can see here that we've got a few outliers as well, and you can see where it fits in memory. And now what we're going to do is we're going to create a random number generator. RNG equals np.random.random state 42, and then what we're going to do is we're going to make it so that 0.6% of the rows are unlabeled. And if it's unlabeled, it's given a -1. A -1 is letting the algorithm know that it's unlabeled. So random underscore unl equals rng.rand, brackets df.class, shape, square brackets 0, square brackets, brackets, less than 0.6, df.class, brackets random unl, brackets equals -1. So it's giving these columns a label of -1, and what that will do is that will let the label spreading algorithm know that it's unlabeled. So now here you can see all the -1s, 60% are -1s. So now we do df class dot value count. So you've got 126 -1s, 143, and 039. And now what we do is we define our dependent and independent variables. Y is your dependent variable, so it's the last column in the data set. So y equals df.iloc, square brackets, colon, comma, -1, square brackets. And then x is your independent variable, and it's all of the columns except for the last column in the data frame. So x equals df.iloc, square brackets, colon, comma, colon, -1, square brackets. So that lets you know that it's all the columns except for the last one. And then so we check our shape, and you can see our shape. So now we're going to use the label spreading algorithm. So ls underscore model equals label spreading, brackets dot fit x y, ypred equals ls model dot predict x, and then ypred. So you can see it's all ones and zeros. So all of the -1s have been converted to a 1 or a 0, and that is what label spreading algorithm is supposed to do. We check the accuracy of this. The accuracy is 87.9%, which is good. And then we put it on a confusion matrix, so you can see how many false positives and false negatives that you got. And now we put it on a data frame so you can compare the true labels with the predicted labels. And so that's it. That covers it for the self-spreading, the semi-supervised label spreading algorithm. And we've talked about the code, and I will be making a blog post where I'll be talking a little bit more about the theory of a label spreading algorithm as well. So I hope you enjoyed this video. Thank you all my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you for watching my video. I look forward to making more code reviews for you in the future.